The electrical situation involves inadequate underground wiring. The existing number 1 wire size is not suitable for the current load, and only 3 wires were run, which is insufficient for a modern electrical panel. To resolve this issue, upgrading the underground wiring is necessary. Firstly, it is critical to obtain a permit. Contact the local building department to acquire the necessary permit for the electrical work. Secondly, trenching is required. Dig a trench from the cottage to the desired location of the new outdoor panel. Thirdly, install new wiring. Run new number 2 THHN or number 2 XHHW electrical wires in conduit from the cottage to the outdoor panel. It is crucial to use 4 wires, including 2 hot, 1 neutral, and 1 ground. Fourthly, connect the new wires to the appropriate terminals in the new outdoor panel. Fifthly, disconnect the existing number 1 wires from the interior panel. Sixthly, seal the trench by filling it with soil and compacting it. Seventhly, call for an inspection. Once the work is complete, schedule an electrical inspection to ensure it meets code requirements. Several additional considerations should be taken into account. The kitchen panel should be located in an accessible and visible location outside the cottage. Consider using a 125 amp outdoor panel to provide adequate capacity for future electrical needs. If any unexpected issues arise during the installation, consult a qualified electrician for professional guidance. When selecting the appropriate gauge and type of wire for the underground feeder, several factors must be considered. These factors include the ampacity of the conductors, the voltage drop, and the environmental conditions. Ampacity refers to the current carrying capacity of a conductor, which is determined by its size and insulation type. The ampacity must be sufficient to handle the expected load without overheating the wire. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to malfunction. The National Electrical Code, or NEC, provides tables and formulas for calculating voltage drop. Environmental conditions such as moisture, temperature, and exposure to sunlight can also affect the choice of wire. For underground installations, it is essential to use wires that are specifically rated for direct burial or are installed in conduit to protect them from physical damage and corrosion. THHN and XHHW are commonly used wire types for underground applications. THHN is a thermoplastic high heat resistant nylon coated wire, while XHHW is a cross-linked polyethylene high heat resistant water resistant wire. Both types are suitable for wet and dry locations, but XHHW has better moisture resistance. The size of the conduit should be selected based on the number and size of the wires being installed, as well as the applicable codes and standards. It is important to use the correct type of conduit for underground installations, such as rigid metal conduit, RMC, or rigid polyvinyl chloride conduit, PVC. These conduits provide physical protection for the wires and help prevent damage from moisture, chemicals, and other environmental factors. When installing underground wiring, it is essential to follow all applicable codes and standards. The NEC provides detailed requirements for underground installations, including minimum burial depths, conductor sizing, and grounding. It is also important to coordinate with local utility companies to ensure that the installation does not interfere with existing underground infrastructure. The minimum burial depth for underground wiring depends on the voltage and type of wiring. For example, direct burial cables typically require a greater burial depth than cables installed in conduit. The NEC specifies the minimum burial depth for various types of wiring in Table 300.5. Grounding is an essential safety measure for electrical systems. It provides a low resistance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Underground wiring systems must be properly grounded to ensure safety and prevent damage. The grounding conductor should be sized according to the NEC and connected to a grounding electrode system. The grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode. When connecting wires to terminals in the electrical panel, it is essential to use the correct type of connectors and tighten them properly. Loose connections can cause overheating and arcing, which can lead to fires. The connectors should be rated for the size and type of wire being used. The terminals in the electrical panel should be clean and free of corrosion. It is also important to follow the manufacturer's instructions for installing and tightening the connectors. When disconnecting the existing number 1 wires from the interior panel, it is essential to turn off the power to the circuit breaker or fuse that supplies the panel. This will help to prevent electrical shock. It is also important to label the wires before disconnecting them so that they can be reconnected correctly. The wires should be disconnected carefully to avoid damaging them or the terminals in the panel. When filling in the trench with soil and compacting it, it is important to use the correct type of soil and compact it properly. The soil should be free of rocks and debris that could damage the wires or conduit. The soil should be compacted in layers to ensure that it is firm and stable. This will help to prevent the trench from settling and damaging the wiring. When scheduling an electrical inspection, it is important to have all of the necessary documentation available. This documentation should include the permit, wiring diagrams, and equipment specifications. The electrical inspector will review the installation to ensure that it meets all applicable codes and standards. If the installation passes inspection, the inspector will issue a certificate of approval. If the installation fails inspection, the inspector will provide a list of deficiencies that must be corrected. When choosing an outdoor electrical panel, it is important to select one that is rated for outdoor use. Outdoor panels are designed to withstand the elements and protect the electrical components from moisture, dust, and other environmental factors. The panel should be made of corrosion-resistant materials and have a weatherproof enclosure. It should also be sized appropriately for the expected load. When using a 125 amp outdoor panel, it is important to ensure that the service entrance conductors are sized appropriately. The service entrance conductors are the wires that connect the panel to the utility's power supply. The size of the service entrance conductors must be sufficient to handle the expected load without overheating the wires. The NEC provides tables and formulas for calculating the size of service entrance conductors. When encountering unexpected issues during the installation, it is important to consult a qualified electrician. A qualified electrician has the knowledge and experience to troubleshoot electrical problems and provide safe and effective solutions. They can also ensure that the installation meets all applicable codes and standards. It is always best to err on the side of caution when working with electricity. Safety precautions are crucial when working with electricity. Firstly, always turn off the power before working on any electrical circuit. This will help to prevent electrical shock. Secondly, use insulated tools when working with electricity. Insulated tools provide a barrier between the electrician and the electrical current. Thirdly, wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. PPE can help to protect the electrician from injury. Fourthly, never work on electrical circuits in wet conditions. Water is a good conductor of electricity, and working in wet conditions can increase the risk of electrical shock. Fifthly, follow all applicable codes and standards when working with electricity. Codes and standards provide guidelines for safe electrical installations. Sixthly, if unsure about something, consult a qualified electrician. A qualified electrician has the knowledge and experience to troubleshoot electrical problems and provide safe and effective solutions. When selecting an outdoor panel, consider the number of circuits needed. The number of circuits needed depends on the number of appliances and equipment that will be connected to the panel. It is always best to choose a panel with more circuits than needed to allow for future expansion. The panel should also have a sufficient number of spaces for circuit breakers. When installing the outdoor panel, it is important to mount it securely to a wall or other structure. The panel should be mounted at a height that is easily accessible and visible. The panel should also be protected from physical damage. When running conduit underground, it is important to slope it slightly to allow for drainage. This will help to prevent water from accumulating in the conduit and damaging the wires. The conduit should also be sealed at the ends to prevent water from entering. When connecting wires to circuit breakers, it is important to use the correct size and type of circuit breaker. The circuit breaker should be rated for the size of the wire being used. The circuit breaker should also be compatible with the panel. It is also important to tighten the screws in the circuit breaker securely. When labeling the circuit breakers, it is important to use clear and accurate labels. The label should identify the circuit that each breaker controls. This will make it easier to identify and troubleshoot electrical problems in the future. When testing the electrical system, it is important to use a qualified electrician. A qualified electrician has the knowledge and experience to test the electrical system safely and accurately. They can also identify and troubleshoot any electrical problems. When using a generator, it is important to follow all safety precautions. Generators can produce dangerous levels of electricity. It is important to operate the generator in a well-ventilated area and to avoid touching the generator while it is running. It is also important to use a transfer switch to connect the generator to the electrical system. When using extension cords, it is important to use the correct size and type of extension cord. The extension cord should be rated for the amount of power that will be drawn by the appliance or equipment being used. The extension cord should also be in good condition and free of damage. When plugging appliances and equipment into outlets, it is important to avoid overloading the circuit. Overloading a circuit can cause the circuit breaker to trip or the fuse to blow. It can also damage the wiring and cause a fire. When working on electrical projects, it is important to take breaks to avoid fatigue. Fatigue can impair judgment and increase the risk of accidents. It is also important to stay hydrated and to avoid working in extreme temperatures. When storing electrical equipment, it is important to store it in a dry and secure location. Electrical equipment should be protected from moisture, dust, and physical damage. It should also be stored out of reach of children. When disposing of electrical equipment, it is important to dispose of it properly. Electrical equipment contains hazardous materials that can pollute the environment. It is important to recycle electrical equipment whenever possible. When hiring an electrician, it is important to choose a qualified and licensed electrician. A qualified and licensed electrician has the knowledge and experience to perform electrical work safely and effectively. They should also be insured and bonded. Understanding the NEC is crucial for safe electrical installations. The NEC is a comprehensive set of standards that governs the installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and safety practices. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and bonding. The NEC is not a law, but it is adopted by many states and local jurisdictions. It is important to consult the NEC when planning and installing electrical systems. Understanding electrical safety is essential for preventing accidents and injuries. Electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical shock. Always turn off the power before working on electrical circuits, use insulated tools, and wear appropriate personal protective equipment. If you are unsure about something, consult a qualified electrician. When selecting wire, consider the insulation rating. The insulation rating of a wire indicates the maximum temperature that the wire can withstand without degrading. The insulation rating is typically expressed in degrees Celsius. Common insulation ratings include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The appropriate insulation rating depends on the application and the ambient temperature. When selecting conduit, consider the material. Conduit is available in a variety of materials, including metal, plastic, and fiber. The appropriate material depends on the application and the environmental conditions. Metal conduit is strong and durable, but it can corrode in wet environments. Plastic conduit is lightweight and corrosion resistant, but it is not as strong as metal conduit. Fiber conduit is lightweight and non-conductive, but it is not as durable as metal conduit. When selecting circuit breakers, consider the interrupting rating. The interrupting rating of a circuit breaker indicates the maximum amount of current that the breaker can safely interrupt. The interrupting rating is typically expressed in amperes. The appropriate interrupting rating depends on the available fault current at the point of installation. The available fault current is the amount of current that would flow in the event of a short circuit. When selecting grounding electrodes, consider the soil conditions. The soil conditions can affect the effectiveness of grounding electrodes. Sandy soils are typically less conductive than clay soils. The NEC specifies the minimum requirements for grounding electrode systems. The grounding electrode system should be tested periodically to ensure that it is functioning properly. When selecting connectors, consider the compatibility. Connectors must be compatible with the wire and equipment being used. The connectors should be rated for the size and type of wire being used. The connectors should also be compatible with the terminals in the electrical panel. It is important to use the correct type of connectors to ensure a safe and reliable connection. When selecting labels, consider the durability. Labels should be durable and resistant to fading and peeling. The labels should be able to withstand the environmental conditions in which they will be used. The label should also be easy to read and understand. It is important to use clear and accurate labels to identify electrical components and circuits. When selecting tools, consider the quality. Tools should be of good quality and designed for the specific task at hand. The tool should be in good condition and free of damage. It is important to use the correct tools to ensure a safe and effective installation. When working with electricity, it is important to be aware of the potential hazards. Electricity can cause shocks, burns, and even death. It is important to take precautions to protect yourself and others from electrical hazards. Always turn off the power before working on electrical circuits, use insulated tools, and wear appropriate personal protective equipment. If you are unsure about something, consult a qualified electrician. Maintaining electrical systems is essential for ensuring their safety and reliability. Electrical systems should be inspected periodically for signs of damage or wear. Loose connections should be tightened, and damaged components should be replaced. It is also important to keep electrical equipment clean and free of dust and debris. Properly maintained electrical systems are less likely to cause accidents or injuries. Consider local Lockport, Illinois regulations, which may exceed national standards.